Hi, this is Joshua coming to you from here in Abbotsford, British Columbia. Over the weekend I've been doing some of my first experiments using heat to produce voltage in a thermocoupler. At the time I was using a piece of 8-inch 3/4 copper connected to a same length of steel, and I actually got 2 volts, ended up blowing my multimeter. It's going to have to get something with a wider voltage setting. Anyway, what I'm bringing before you is a new series of application using the Joepipe as to build a thermo-coupler array. In this Joepipe application, I'm using the star stove as the Joepipe heat source to build this array. So I'm just going to go back here. More or less just want to focus. If I had a cameraman, I wouldn't have this problem. Okay, we go from here. So this is an intro into the possibilities of using the Joepipe to build new thermocoupler systems. So knowing that I've already got, it can produce 2 volts using a length of copper and steel, only needs the heat source. So if we have one here, this is your hydrogen burn coming out from your star stove. We know that this is going to produce 2 volts DC. So if we put this into a bank, I'm going to use 6 here for the bank, and your diameter of your copper could be anywhere from, say, ½ inch. ½ inch would be fine. ½ inch copper pipe joined into a piece of steel. Yeah, it's a little better. It's hard getting the setting here. Okay, that should work. So if we have 6 copper pipes coming vertically above the flame, and if we attach the steel part of the pipe below the star stove, we can actually put that into a connect all 6 into a steel holder, so your amperage would be added together, but you still be able to separate your voltages here or connect your voltages. And so we want to test to see if all 3 or all 6 copper pipes are going to produce the similar voltage, and what will happen if you can actually just connect it together with a copper plate. So you basically have a, if I can draw this here, this would be your pipes, and where's my black? This would be your steel, and we're using pipes here, or it could be a piece of steel rod going into a 1/4 inch or ½ inch copper. And what we're going to do anyway on the first test, we're just going to make a holder here, and so you know that your heat source is going to be about here. This would be your star stove, and your heat is coming out through the sides to heat that. That's more of a side shot. But if it is possible to have 12 volts at whatever the voltage is going to be, then we know that we can make 6 more of these arrays, and you should get 12 times 6 equals 72 volts DC. I think this is going to prove to be a very interesting test, and it may bring the application of using heat for producing power from thermocouplers into a whole new array. This is probably stuff that's already been done, 100 years ago. A lot of that science has been lost, and as in any experimentation, you need imagination to make it work. Okay, this is one application I'd like to try, so we could actually start using one to see what the voltage is going to be and put it together into a bank to see what the combined voltage is going to be. The next step, knowing that you're working with two steel plates, and the plates will be about a 1/4 inch thick because of the heat. You need that. What will happen if we insert these pipes into the star stove itself, where the copper would be fitted to the top plate like this, right? It actually come through, so you have your junction point there, and you have your, say for this setup, we're going to have a steel rod going into the copper pipe to form the junction, and as your heat comes out from the center, your level 3 heat be coming out from the center to spin around the pipe. So the pipe's going to get, both the copper and the steel is going to turn yellow point, at least red hot. And as we know that our copper is embedded in the steel, that forms a junction there, and the steel is embedded into the steel plate. That doesn't really form a junction, more or less extends the steel, but the steel goes into the copper that forms your second junction. Now what will happen? Is this going to take away? Is this going to improve? Is this going to produce some kind of anomaly? And that's what we want to find out. But where I'm leading to this, what would happen, I need more room here. What would happen if we took the combined voltages, and you got it, that's a car coil, and connected the negative voltage with the amperage side, the steel side, with the positive side to charge your coil. You could even maybe replace the car coil with a Tesla coil, or add a Tesla coil to the takeoff. And so I say, for example, you're using the Joepipe Thermo-Coupler array to charge a car coil, right? Car coil. And so if you bring the voltage down to here, and you make, we want to make this voltage work. You've got 2 plates of glass, you shield off, and you fill the gap with water. And what would happen if you took the hot side of the coil and hook it to a carbon rod? So the carbon rod would be touching the glass, and you take the I guess you could form this ground back to your the amperage or the ground side of your thermocoupler. Now, is this going to produce some kind of discharge here, to where you're producing a plasma discharge in the water to produce your HHO? So this is the first steps that I would like to take. There are a few preliminary tests to see whether or not the flame will actually join the, if you have a fire brick